Good morning to all. So today we'll try to understand that why we measure the strength of yarn, fiber, fabric, different textile materials, and how do we measure it? What are the various approaches we have used in designing the tensile testing instruments? Now, the first thing is why we measure the strength of yarn. Now, two things are required from yarn is high efficiency during subsequent processing steps, winding, warping, and on loom also. So to reduce the end breakage, to minimize the end breakage. And the second thing which we require from the strength characteristic is it is directly related to quality of the material. That is during the use in apparel or different industrial uses, we need the strength. So there are two aspects. One is during processing, the yarn should give higher efficiency, and the other is we should get the good quality fiber yarn or fabric for various end uses in apparel or industrial, etc. Now the approach is to how to assess the strength. Generally, there are different approaches. One of them is we have already studied theoretically, that is breaking, load, and extension. We just take the sample, whatever fiber, yarn, or fabric, and we find out the load required to break that sample and the extension produced in that sample. That is breaking extension. That is one way. Now, in case of specific things such as where the ability to stand shocks is required, sudden shocks are there in particular end uses such as car seat belts, climbing ropes. When we have to select the material for these end uses, then we go for the testing work of rupture, and for that ballistic or impact type of testers are used, which give the results in joules, that is energy required to break the specimen. One more approach which is used only for yarns. Please note, it is only for yarns, and that is constant tension winding test. Now, as we have said that we need to assess the strength to improve the efficiency of the subsequent processes such as winding, warping, or on weaving, on loom. Now, what is the thing which is affecting the efficiency is the end breakage. Now, end breakage produced in the yarn at very high speed is more related to the CV% of the single yarn strength as compared to mean yarn strength. We need to understand that end breakages occur at weakest point. So mean strength doesn't give us an idea about the frequency of the weak points in the yarn. So constant tension winding test has been designed so that it is closer to actual running conditions, just the way yarn runs on a winding machine. The high speed of that as well as the longer length is also there. So it gives the results in the form of breaks per 1000 yards or breaks per 1000 yards at given tension, and tension required to get standard breakage rate, which is 8 breaks per 1000 yard. We need to understand this, that we take a yarn and we just make it run on given tension, and we measure the number of breaks at that given tension. Or the other way, we can measure the tension required to get the 8 breaks per 1000 yard. So the main point is here is that it is very important to calculate the CV% of single yarn strength also, which is related to the efficiency required to improve the efficiency in the subsequent processes after making yarn. Now coming back to the main two things, that is breaking, load, and extension measuring instruments, and work of rupture measuring instruments. We'll go through the individual instruments one by one, but presently we need to understand just a summarized view of all these things. So under breaking load and extension, we will study different instruments: stellometer, Presley, inclined plane tester, Cambridge extensometer, and this Instron universal tensile tester, TensoJet, TensoRapid. Now, what are the differences between all these things? We need to understand. Okay, whenever you are studying a testing instrument, tensile testing instrument, first thing you need to understand, classify it. Is it for fiber, for yarn, or for Lee, or for fabric? One thing. Second is it based on CRL principle, CRE principle, or CRT principle? We have already discussed CRL, CRE, and CRT. Generally, nowadays, Instron is a company name. Instron Universal Tensile Tester is popular, which is a CRE as well as CRT based tester. Now, the second thing we need to understand about any instrument is it based on gravimetric principle or spring? Spring and gravimetric, two types of instruments will be there. In gravimetric type of instruments, tension produced in the specimen is balanced against pull of gravity of a known mass. And in spring measurement principle, tension in the specimen deflects a spring of known modulus, so that deflection of spring gives the tension. These are the definitions. We need to understand it in simple words. If we have to measure 1 kg of potatoes or any 1 kg of any material, we can do it in two ways. One is beam balance and one is spring balance. In case of beam balance, we balance the weight of the material with the known weight. That is basically gravimetric principle. And when we balance the weight of the material with the deflection produced in the spring, you must have seen those spring balances. That type of things will come under spring principle. Now, if we have to classify the tensile testing instruments under these categories, under gravimetric, we will study stellometer, inclined plane tester, Presley tester. Stellometer and Presley are very popular for fiber bundle strength testing. Note the point. For fiber bundle strength, we generally use stellometer and Presley. Nowadays, Presley principle is used in case of HVI. We have studied in last semester. And in case of yarn and fabric and Lee, we generally which is available is Instron Universal Tensile Tester, and nowadays better options are available, that is TensoRapid and TensoJet also. Now, TensoJet is only for yarns. You have to remember these things. We'll discuss it one by one. Now, gravimetric always gives you some sort of inertia errors. And under spring testing, tensile testing instruments, we will study as we know, there are two types of spring. One is helical spring and one is leaf spring. Helical spring you have seen in your pens also, and leaf spring is just a plain metal strip type of spring. Under helical spring principle, we'll study Cambridge extensometer, and leaf spring is more popular, which is used in case of Instron Universal Tensile Tester and TensoJet and TensoRapid. Ooster TensoJet and Ooster TensoRapid. One more thing we need to observe here is the maximum speed of the jaw is 1 meter per minute in case of this Universal Tensile Tester by Instron, and these two Ooster products, Ooster TensoRapid, maximum speed is 5 meter per minute, and Ooster TensoJet gives 400 meter per minute maximum speed, and only it is used in case of yarns. Other two can be used for fiber yarn or fabric. Universal word is used because it is universal. It is universally used for fibers, yarns, and fabrics. Thank you for today. So we have understood the various approaches, that is, we measure breaking load in terms of Newton or kgf and extension in units of length, or we can measure work of rupture for sudden shocks type of end uses, and constant tension binding test is used for yarns to uh, give to give actual running conditions experience and to give us an idea about the end breakages which may occur. So what is the importance of CV of single yarn strength? This is an important aspect. And now in the next class we'll study individual instruments, pendulum lever based, stellometer, inclined plane tester, Presley based on balance principle, Cambridge extensometer, which is a helical spring principle, and this universal tensile tester, which is based on this leaf spring, and this ballistic or impact tester, which is based on work of rupture measurement. Okay, thank you for today.